Want to add AI to apps and workflows in a way that feels natural to users and still stays grounded, secure, and maintainable? Hi and welcome. I'm Georgia, lead technical trainer at Microsoft, and in this session, we will cover generative pages and agent feeds for apps, how to design in Copilot Studio, grounding and data processing, intelligent application design, and success criteria for AI business solutions. Let's get started. By the end of this video, you will learn two key things. First, building task-focused and autonomous agents using Copilot Studio, going deeper in the practical design patterns and implementation details. And second, how to implement prompt-driven conversational agents with adaptive responses, where you will learn to create agents that handle dynamic conversations intelligently. Let's start by exploring generative pages and agent feeds for applications. This is where AI agent design meets the user interface. Let's talk about generative pages in model-driven apps. This is a game changer for development speed. Instead of manually building every page layout, app makers can now describe what they need in plain language. For example, you might type something like, create a customer overview page showing recent orders, open cases, and satisfaction score. And Power Apps generates the layout, data connections, and UI structure automatically. This removes hours of repetitive scaffolding work. For architects, this means faster prototyping and more time spent on the design decisions that actually matter. Think of it as AI handling the boilerplates so your team can focus on business logic and user experience. Code-first extensions are critical when generative pages alone are not enough for enterprise requirements. As agentic AI architects, we need comprehensive knowledge of Power Platform, alongside deep customization skills. JavaScript handlers, custom PCF controls, and Dataverse logic let you extend AI-generated foundations with precision engineering. The best practice here is to let AI handle the scaffolding, then apply code-first extensions only where business complexity genuinely demands it. This decision table is a practical reference for when to reach for code-first development. As an agentic AI architect, one of your key responsibilities is analyzing business and technical requirements to architect comprehensive solutions. Complex business rules, custom UI, cross-system integration, performance optimization, and compliance all signal code-first needs. The architectural best practice: start with generative approaches for speed, then layer in code where precision and control are non-negotiable. Agent feeds represent the intelligence layer inside your applications. Agents should be conversational and autonomous, interpreting data, making decisions, and automating tasks. An agent feed does exactly that by monitoring context, surfacing insights, and recommending next best actions in real time. As an architect, your best practice is to design agent feeds with clear boundaries, ensuring the agent only surfaces actionable, trustworthy insights aligned with your organization's goals. Knowing when to combine generative pages, agent feeds, and code-first extensions is a core architectural decision. Ask yourself, does the use of AI deliver value that balances complexity? For rapid screens, use generative pages. For intelligent guidance, add agent feeds. For deep customization, layer in code. High-volume automation scenarios combine all three. Your best practice is to always match the tool to the task. Never over-engineer. This architectural diagram shows how the generative page and agent feed work together. We, as architects, must design scalable, secure, and integrated solutions. So notice the clean separation. The generative page owns structure and layout, while the agent feed owns the intelligence layer. As an architect, maintaining this separation of concerns is a best practice that makes your solutions easier to maintain, extend, and troubleshoot as requirements evolve over time. This comparison table is good to begin with. We need to select the right AI model and apply it at the right stage of the process flow. Prompt first is fastest for prototyping. Code first gives you full control for enterprise complexity, and agent-driven approaches deliver adaptive intelligence. The best practice? Rarely choose just one approach. The strongest solutions blend all three, mapping each requirement to the most appropriate method. In our next section, we're diving into designing topics for Copilot Studio, including fallback handling. Topics are the core building blocks of conversational logic in Copilot Studio. As architects, we must design agents that combine structured scenarios with generative responses. Each topic defines a user intent, a response flow, and connected actions. The system selects topics through trigger phrases, natural language matching, and generative understanding. Your best practice is to design topics that handle predictable requests precisely while remaining flexible for unexpected variations. This is the operability pillar in practice. Understanding the key components of topics is essential for any agentic AI architect. We need to build proficiency in working with agents created using Copilot Studio. Trigger phrases initiate topics, message nodes deliver information, question nodes gather structured inputs, and conditions route conversations. Finally, actions connect to external systems. Your best practice is to think of these components as your conversational design toolkit. Each serves a distinct purpose, and mastering their interplay is what produces agents that feel natural and effective. Here are practical guidelines for designing strong topics. Start with real user intents, not assumed ones. Write the trigger phrases in natural user language, not technical jargon, and keep the flows short and focused. Use variables for continuity, so users never repeat themselves. Reuse components for shared logic. The best practice here is simplicity. A well-designed topic feels effortless to users, and that effortlessness requires thoughtful and deliberate architecture from you. The system fallback topic is critically important. It handles every message that doesn't match any defined topic, and that's going to happen more than you might expect. A well-designed fallback acknowledges the gap honestly, offers clear alternatives, can escalate to humans, and captures feedback for improvements. The best practice is to invest as much design effort in your fallback as in your primary topics. This is responsible AI in action. Let's review the different topic types available in Copilot Studio. Instructional topics guide tasks, action topics automate steps, informational topics answer questions, system topics handle events like greetings and fallbacks, and reusable topics share logic across flows. The best practice is to map every user scenario to a topic type during design to quickly identify coverage gaps. This diagram illustrates how Copilot selects the right topic when a user sends a message. The process flows from the user message through intent analysis, which evaluates trigger phrases, natural language understanding, and generative orchestration. As a best practice, invest in strong trigger phrases and natural language understanding configuration to maximize matching accuracy and always ensure your fallback handles the rest gracefully. Let's wrap up this section with best practices for topic and fallback design. Make sure you prioritize clarity and brevity in every message your agent sends. Use structured questions with clear options when you need specific inputs. Leverage entity extraction to pull key data from user messages automatically. And make sure you maintain a consistent tone aligned with the Microsoft Writing Style Guide. Your fallback should feel supportive, not abrupt or dismissive. And critically, test with real-world phrasing, not the perfectly worded prompts your team writes in a conference room. Real users phrase things in unexpected ways, and your topics needs to handle that gracefully. Now let's move on into designing data processing for AI models and grounding. Grounding is what keeps your AI responses accurate, current, and trustworthy. Without it, even the best models can produce unreliable outputs. Why do data processing and grounding matter so much? Grounding supplies trusted, task-relevant data to the AI model at inference time. This is what enables accurate and current responses. Without grounding, your model relies solely on its training data, which may be outdated or lack your organization's specific context. Microsoft emphasizes retrieval augmented generation, or RAG, as a core pattern for enterprise AI. And Azure well-architected guidance highlights that data design should be iterative, not a one-time setup. Grounding is where you ensure your AI solutions deliver real business value, rather than generic responses. The ingestion and preparation stage sets the foundation for your entire ground pipeline. We must design secure and scalable solutions, and this starts with data handling. Start with trusted sources, normalize formats, enrich with metadata, and respect data sensitivity labels throughout. The best practice is to preserve classification labels from source to index and avoid indexing unnecessary personal data. Getting ingestion right means getting responsible AI right from the very first step. Chunking and embeddings directly impact your agent's response quality and cost. Choose chunk sizes that respect semantic boundaries and fit within your model's context window. For search, prefer hybrid approaches combining vector similarity, keyword matching, and semantic ranking. The best practice here is that poor chunking increases token costs and degrades answer quality. So make sure you test your chunking strategy with real queries and iterate until results are consistently accurate. Your indexing strategy determines the retrieval efficiency for the entire grounding pipeline. Externalize data into a dedicated search index rather than querying live systems. Be intentional with your schema, making fields as searchable only when genuinely needed. The best practice is to start with a single index for simplicity. Only split indexes when distinct compliance or audience requirements demand separation. Simpler architectures are easier to maintain. Retrieval and orchestration bring the grounding pipeline together. Combine vector queries, keyword search, and semantic re-ranking for the most reliable results. Make sure you construct grounded prompts that cite their sources, enabling auditability and compliance traceability. The best practice here is to tune your top K carefully. Too few results miss context, too many introduce noise and increase costs. Finding that balance requires testing with real queries from real users. AI search provides the retrieval backbone for enterprise-scale grounding. Microsoft Foundry offers managed RAG capabilities for agents and apps. Copilot Studio and AI Builder enable low-code grounding on Dataverse data. The best practice to remember here is to match the platform to your team's capabilities and your solution's requirements. Organizations with strong developer teams may lean towards Azure AI Search, while teams invested in Power Platform can use the low-code path effectively. Let's review the key design decisions and their trade-offs. For retrieval mode, hybrid search delivers the best results in most scenarios. For chunking strategy, use semantic chunks that respect natural content boundaries. For index topology, start with a single index unless you have distinct compliance or audience needs. And for data freshness, set your update cadence based on a defined service level objective. Don't refresh more often than your business actually requires. Each of these decisions impacts cost, performance, and response quality. Document your rationale for each choice because these trade-offs will come up in every architecture review. This diagram shows the complete grounded AI data flow. Follow the path from authoritative data sources through ingestion, chunking, and embedding generation, into the search index through retrieval, into the grounded prompt, and finally to the AI-generated response. This awareness is essential for maintaining production AI systems. These three implementation patterns give you a practical toolkit for grounding scenarios. Pattern A uses Azure AI Search with RAG for maximum flexibility. Pattern B leverages Microsoft Foundry for managed agent grounding. Pattern C uses the Power Platform for low-code scenarios on Dataverse data. The best practice to remember here is that these patterns are not mutually exclusive. Many enterprises use different patterns for different workloads. Match each use case to the best fit pattern. So let's cover the operational considerations that keep your grounding solution healthy in production. Operational considerations keep your grounding solution healthy by controlling costs with minimal viable schemas and capped token budgets. Make sure you preserve security labels and access controls throughout the pipeline. Iterate with real queries measuring quality, citation correctness, latency, and coverage. The best practice here is to build monitoring into your architecture from day one. Grounding systems require ongoing attention, not deploy and forget approach. Our next part focuses on designing a business process that includes AI components in a Power Apps Canvas app. We'll walk through a structured approach to identifying where AI adds genuine value in your workflows and how to integrate Copilot features effectively. AI-enabled apps in Power Apps streamline tasks, reduce manual data entry, and provide intelligent guidance to users. Power Apps Copilot enables makers to refine logic, modify tables, and generate screens using natural language. The key AI components to understand are AI-assisted data creation, which helps populate records intelligently, Copilot-driven generation for building up elements from descriptions, and AI-powered workflows that automate all these multi-step processes. The important insight here is that AI isn't a separate feature bolted onto your app. It's woven into the development experience itself, making both the building and using of applications more efficient. Copilot in Power Apps Studio lets makers update app logic and data simply by describing changes in natural language. You can add fields, update validation rules, generate screens, and modify relationships through natural language. As an agentic AI architect, this capability lets you focus design guidance on strategic decisions while empowering your team to handle implementation details through Copilot interactions. Shift your role toward quality gate and strategic advisor. Copilot-driven business solutions start with plans that structure your business processes before you build anything. When you describe what you need, Copilot interprets your requirements and proposes screens, entities, workflows, and data operations. Your role as an architect shifts towards validating and guiding AI-generated proposals rather than specifying every detail. This makes your expertise even more valuable as a quality gate, ensuring AI-generated designs meet the enterprise requirements and they follow the best practices you set. Step 1 of the structured design method is mapping your current workflow. Identify actors, inputs, decision, automated candidates, and error-prone steps. The best practice here is never skip this step. You cannot effectively design AI enhancements without understanding the human process first. This mapping creates the foundation for everything that follows and prevents you from automating the wrong things or missing high-value opportunities. Step 2 is identifying where AI adds the most value. AI is most effective for repetitive data updates that consume time without requiring judgment. Data interpretation and summarization where humans struggle with volume. Providing guidance and recommendations based on patterns is important. Natural language acceleration that speeds up interactions and automating multi-step processes that follow predictable patterns. So as an architect, just be selective. Not every step needs AI. Focus on the areas where the impact is highest and the risk is manageable. The best AI implementations target specific pain points rather than trying to automate everything at once. We start simple and expand based on results. Step 3 focuses on designing user interactions with Copilots. The right agent must be available to end users in the right clients at the right time. You have several patterns: chat panels, suggestion bars, auto-generated summaries, natural language record creation, and validation recommendations. So choose interaction patterns based on your specific user personas. A data entry clerk needs different AI interactions than a manager reviewing dashboards, so always design with the end user's workflow in mind. Step 4 integrates Copilot features directly into Power Apps Studio. Generate screens from data, propose schema updates, build tables from descriptions, suggest formulas really easy, and support the ongoing refinements. The best practice here is to design your solution architecture to accommodate iterative improvements, rather than treating initial deployment as the final state. Copilot integration is not a one-time event. It supports continuous enhancement as your business needs evolve. Step 5. Validating security and governance. Ask what data the AI can access, what actions it can take, where your DLP boundaries are, and whether everything complies with internal governance. The best practice here is to build security validation into your design from day one as an afterthought. As an agentic AI architect, applying responsible AI principles, ensuring AI never exceeds established security boundaries is among your most critical responsibilities. This table gives us a practical checklist for integrating AI into business processes. Data capture benefits from AI-generated fields, evaluation phases from Copilot suggestions, document creation from AI-generated text, navigation from assistants, data updates from natural language editing, and workflows from AI-initiated actions. The best practice here, for each area, deliberately decide whether AI adds genuine value or just introduces unnecessary complexity. This is the complete workflow for an AI-enabled Canvas app. Follow the flow from user interaction through Copilot processing to the resulting actions and data updates. Notice how AI components integrate at multiple points in the workflow, rather than sitting in isolation. This view helps you understand the touch points where AI enhances the user experience and where traditional logic still handles the processing. When presenting your solution design to stakeholders, a diagram like this clearly communicates where AI fits and where human oversight remains. That clarity builds confidence in your AI-enabled design. In this part, we'll apply the Microsoft Power Platform well-architected framework to intelligent application workloads. This framework gives you a structured approach for evaluating and improving your AI-enabled solutions across 5 key pillars. The Power Platform well-architected framework provides a structured approach for designing workloads that meet current needs while adapting to future challenges. It focuses on 5 pillars: building reliable workloads, increasing security, improving operational efficiency, and finally optimizing performance and delivering outstanding user experiences. This framework is aligned with the Azure well-architected framework, so the principles translate across your entire technology stack. This isn't just a checklist, it is a lens for evaluating every design decision. When you add AI components to the Power Platform solutions, each pillar has specific implications you need to address deliberately. Reliability is especially critical for AI-enabled workloads. AI components introduce new failure modes: model endpoints going down, grounding indexes becoming stale, connectors timing out. Make sure you build redundant connectors and implement retry policies and design resilient dataverse architectures. The best practice here is to design your solution assuming things will fail and ensure it degrades gracefully. The operability pillar from the agent framework directly reinforces this principle. Security in AI-enabled workloads demands extra vigilance. Make sure you implement least privileged access through Entra ID. Apply DLP policies that account for AI data flows. The best practice here is to use AI components that can amplify security risks by exposing sensitive data across more surfaces. Make sure your AI behaves within the exact boundaries your organization has established. Operational excellence is not about observability, monitoring, and automated governance. Track how AI features are being used, measure response quality and user satisfaction, and set up proactive alerts. You can use the application lifecycle management with Azure DevOps or GitHub. The best practice here is to use AI-specific metrics like response accuracy, grounding, quality, and user feedback rates, and they are just as important as uptime and latency. Build them into your monitoring from the start. The performance efficiency pillar ensures your solution adjusts to demands with scalable architectures. Leverage Dataverse for high-volume data access, offload compute-intensive processing to Azure Functions, and right-size your Power Automate flows. The best practice here is to set clear performance budgets and test under realistic load. A brilliant AI feature that takes 30 seconds to respond frustrates users more than a simple feature that responds instantly. Always optimize for the user experience. The experience optimization pillar ensures your solutions deliver meaningful user experiences that lead to successful outcomes. Make sure you maintain UX consistency across power-ups, implement Copilot-assisted workflows that genuinely help users, and ensure accessibility compliance. The best architecture in the world fails if users find it confusing or unhelpful. So test your AI experiences with real users, gather feedback, and iterate. Technology exists to serve people, and the user experience proves whether it does. This flow shows how Azure well-architected framework principles map directly into Power Platform intelligent applications. Take a moment to trace the connections. Notice how each Azure pillar has a concrete counterpart in Power Platform. This is a useful reference when you're designing or reviewing an agent solution. It reminds you that building on Power Platform doesn't mean leaving enterprise architecture behind. You're still applying the same disciplined thinking, just through a different set of tools and services. Keep this mapping in mind as we move into best practices next. These best practices synthesize the well-architected framework into actionable guidance. Start with business outcomes, not technology. Make sure you design for change because requirements will evolve. Use Dataverse for enterprise-grade workloads and integrate with Azure services where needed. Make sure you evaluate trade-offs between pillars deliberately. The best practice here is to think about every design decision and how it impacts at least one pillar. Document your rationale so your architecture reviews reflect intentional, balanced choices. Next, we're going to explore a decision that every Copilot Studio architect faces. When should you use standard natural language understanding, Azure Conversational Language Understanding, or Generative AI orchestration? Let's start with a high-level overview of the three approaches. Standard Natural Language Understanding, or NLU, relies on rules, patterns, and structured training data. It's predictable and precise. Azure Conversational Language Understanding, or CLU, steps things up with AI-driven classification, giving you better accuracy and entity extraction across more varied inputs. Then there's Generative AI orchestration, which gives large language models to dynamically interpret prompts, maintain conversation flow, and call actions on the fly. Think of these as a spectrum, from highly controlled to highly flexible. Your job is to match the right approach to the right scenario. Standard NLU is your go-to for predictable, well-defined tasks. It's built on rules, patterns, and structured training data, which means you get high precision with low variability. Use standard NLU when you need strict intent matching, when your users submit consistent queries, and when you want deterministic responses every time. Think of scenarios like a help desk bot that handles a fixed set of commands or a routing system where the inputs are well known. The strength here is control. You know exactly what the agent will do because you've defined every path explicitly. Azure Conversational Language Understanding takes natural language processing further with AI-powered classification. It gives you enhanced accuracy in intent recognition and entity extraction, even where users phrase things differently. CLU is ideal when you're dealing with varied natural language, but within defined topic boundaries. Use it when you need scalable, trainable models, high-quality intent recognition, or integration with Azure AI services for multilingual support. A good example is a field service bot where technicians describe problems in many different ways, but within a known domain. CLU handles that variability without sacrificing accuracy. Generative AI orchestration is the most flexible approach. Large language models interpret prompts dynamically. They maintain multi-turn conversation flow. They retrieve knowledge from your enterprise sources and call actions as needed. This is ideal for complex, open-ended, knowledge-driven tasks. Use it when your user provides unstructured inputs, when you need summarization or reasoning, or when the agent must be grounded in enterprise knowledge to give accurate answers. Think of a sales assistant that pulls real-time insights and summarizes account history during a conversation. That's where generative orchestration truly shines. This decision framework helps you match scenarios to the right technology. For structured commands and regulatory accuracy where precision is non-negotiable, standard NLU is your best choice. When you're dealing with moderate variability in how users express themselves, CLU handles that well. For highly variable language, enterprise knowledge grounding, and tasks requiring reasoning or summarization, generative AI orchestration is the clear winner. Use this table as a quick reference during your design phase. And remember, you can combine approaches within a single solution, using NLU for structured paths and generative orchestration for open-ended ones. Let's see how this plays out in real scenarios. For a call center bot, handling fixed phrases like check my balance or reset my password, standard NLU gives you the precision and speed you need. For a field service bot, when technicians describe problems in varied ways, the compressor is making a grinding noise versus unit won't start, CLU handles that variability beautifully. And for a sales assistant that needs to summarize account history, surface real-time insights, and reason across multiple data sources, generative AI orchestration is the right fit. As we said, match the technology to the task complexity. These best practices synthesize the language understanding session. Begin with NLU or CLU for structured tasks. Always enable grounding for generative orchestration. Use guardrails to keep LLM output safe and predictable. In every approach, make sure you evaluate the cost versus performance, as generative approaches consume more compute. The best practice here is to use the right level of intelligence for each task. No more, no less. This principle applies across every aspect of your agentic AI architecture. Now we're moving on to the hands-on design of agents and agent flows with Copilot Studio. This is where architecture meets implementation. Designing agents in Copilot Studio follows a straightforward process built around two key steps: describe and configure. You start by defining the agent purpose, goals, instructions, and behavior using natural language and structured settings. Copilot Studio then generates an initial agent that you can refine. It's a practical workflow that gets you to a working agent quickly while still giving you full control over the final design. When defining your agent, think about 4 key dimensions. What is its purpose? What specific problem does it solve? What behaviors should it exhibit? What tasks should it perform? And what are its operational boundaries, the things it shouldn't do? Copilot Studio takes this definition and generates an initial structure for you to refine. So being precise in this step saves significant rework later. A vague purpose leads to an agent that tries to do everything and that does not do well. A clear, focused definition leads to an agent that delivers real value from day one. An agent is only as good as the knowledge it can access. I've said it before, I'll say it again. So in Copilot Studio, you can connect agents to multiple knowledge sources, including SharePoint sites and folders, Microsoft 365 content, public websites, and leaked knowledge bases. This is where grounding becomes real. Instead of generating responses from general training data, your agent draws from your organization's actual information. Choose your knowledge sources carefully. The right sources ensure accurate, relevant responses. The wrong ones introduce noise and confusion. So always validate that the content your agent accesses is current, accurate, and appropriate for the use case. Beyond knowledge, you can enable additional capabilities to make your agent more powerful. Code Interpreter lets the agent run Python code for calculations, data analysis, or transformations right within the conversation. The Image Generator allows the agent to create visual content on demand. Enrich adaptive cards, responses, gives you structured interactive output that goes beyond plain text. These capabilities are optional, so enable them based on what your scenario actually requires. Not every agent needs to run code or generate images. Start with the capabilities that directly support your business outcomes and add more as needs evolve. Now let's talk about agent flows. These are the automated workflows that extend your agent's behavior beyond conversation. Agent flows let you automate tasks, integrate with external services, and execute multi-step processes. They run natively inside Copilot Studio and are optimized specifically for agent execution. Think of them as the operational backbone of your agents. The agent handles the conversation and decision-making, while the agent flows handle the doing, sending emails, updating records, retrieving data, for example. Together, they create a complete solution that both understands and acts. What makes agent flows compelling? They offer consistent execution, so your automated processes run the same way every time. You get end-to-end visibility into what's happening at each step. They don't require a separate Power Automate license, which simplifies your licensing model. And they support natural language automation, meaning you can describe workflows in plain language to get started. These advantages make agent flows especially attractive for AI architects who want to keep their agent solutions self-contained within Copilot Studio, while still delivering enterprise-grade automation capabilities. Triggers and actions are the building blocks of every agent flow. The trigger defines how the flow starts, whether manually on a schedule or from events like a system event, or even initiated by another agent. Actions define what the flow does. A well-chosen trigger ensures the flow activates at precisely the right moments. Well-designed actions ensure it accomplishes its task reliably. So together, they form the automation foundation of your agents. We have two methods for creating agent flows. The first method is natural language prompting, where you describe the workflow you want and Copilot generates the flow for you. This is great for rapid prototyping and getting a working draft quickly. The second method is the visual designer, a node-based canvas that gives you full control over every step and condition. In practice, the best approach here is to start with natural language prompting, generate a baseline, then switch to the visual designer to refine and optimize. This combines speed with precision, which is exactly what you need in production-grade solutions. Agent flows can become powerful when you connect them to enterprise systems. You can, for example, integrate with Microsoft Forms, Dynamics 365, Dataverse, email services, external APIs, and even custom connectors. This enables multi-step workflows like automatically creating a CRM record when the customer submits a request, sending follow-up notifications, and updating related records across systems. The key consideration here is designing these integrations to be resilient and secure. Use proper error handling, respect data boundaries, and ensure each connection follows the least privilege principle we discussed earlier. It's important to understand the difference between agent flows and cloud flows. Agent flows are licensed through Copilot Studio capacity, while cloud flows require a Power Automate license. They have different trigger types and are optimized for different purposes. Agent flows are best for AI-driven automation that's tightly coupled with your agent's conversational behavior. Cloud flows are best for broader enterprise integration scenarios. You'll likely use both, The decision comes down to where the automation lives, whether it's agent-centric or part of a larger enterprise workflow, and which licensing model fits your organization. Let's wrap up the agent design we talked about with some best practices. Start with a clear business scenario, not the technology. Keep your agent's instruction concise and focused, and use natural language prompting for prototyping, but then refine with the visual designer. Always test the agent and its flows together, not in isolation. Monitor your analytics to understand how the agent performs in real use. And keep your flows modular so you can reuse and maintain them independently. These practices will save you significant time and help you deliver solutions that actually work in production, not just in demos. In this next section, we'll explore prompt actions in Copilot Studio. Prompt actions are one of the most powerful tools for controlling how your agent generates responses, and they are very simple. They behave as reusable instruction blocks, callable whenever needed. The key advantage here is consistency. Rather than hoping the model responds appropriately, you define exactly how it should process input and produce output for each specific task. This level of control is what enterprise deployments demand. The prompt codes template provides a structured framework aligned with on quality and governance. Break prompts into goal, context, instructions, examples, and output format sections. This structure reduces hallucinations, maintains consistency across your team, and aligns output with organizational standards. The best practice here is to adopt the prompt codes template as your standard for all prompt actions. It transforms prompt writing from an art into an engineering discipline that produces reliably excellent results. These three principles will make your prompt actions even more effective. First, task clarity. Use imperative verbs, be specific, and eliminate ambiguity. Tell the model exactly what to do. Second, organizational tone. Follow the Microsoft Writing Style Guide. Clear, concise, and action-oriented, your agent's voice should match your organization's communication standards. Third, control the outputs. Set word limits, define required fields, and specify what content to exclude. These constraints might feel restrictive, but they're what make the difference between an agent that produces reliable output and one that generates unpredictable responses. Prompt actions are versatile. You can embed them in topics to control how your agent responds to specific intents. You can use them in agent flows to process data during automated workflows. They work as fallback logic when the agent encounters unexpected inputs, and they integrate into business processes for structured content generation. Prompt actions work alongside system instructions, knowledge sources, and action blocks, so they complement rather than replace your other design elements. The key is knowing when a prompt action adds value versus when simpler approaches are sufficient. Let's look at the 5 types of prompt actions. Transform rewrites content. Summarize condenses information. Extract pulls specific entities from the text. Generate creates new content. And classify categorizes input. Make sure you use multiple types together within a single agent, matching its task to the most appropriate type. A classification prompt action can route to a generation prompt action, creating a pipeline of precise controlled language model operations. This image shows the prompt action pipeline from start to finish. The message routes to a topic, triggers a prompt action, sends structured instructions to the model, generates the outputs, and applies post-processing. When agent responses miss expectations, use this pipeline to identify exactly where the issue occurs. Is it topic routing, prompt instructions, or post-processing? Systematic debugging produces faster fixes. So here are some best practices from prompt actions. First of all, keep them modular so each one handles a single task. Apply constraints for tone, length, and structure to ensure consistent outputs. Use examples sparingly. A few well-chosen examples are more effective than many. Test with multiple phrasings to make sure your prompt handles real-world input variability. Use the prompt codes template to maintain the structure, and use guarded language so the agent communicates uncertainty appropriately rather than presenting guesses as facts. And document everything for governance because your team needs to understand and maintain these prompts over time. Here, we'll focus on defining success criteria and adoption goals for your AI business solutions. This is where strategy meets execution. Without clear success criteria, you can't measure whether your solution is delivering value. So let's be direct. The number one reason AI solutions fail isn't technology, it's a lack of clarity about what success looks like. Success criteria define the specific outcomes your solution must achieve. Adoption goals guide how you scale those outcomes across the organization. The Microsoft Cloud Adoption Framework provides a structured approach to aligning your AI initiatives with business objectives. Together, success criteria and adoption goals give your stakeholders a clear picture of what you're building, why it matters, and how you'll know when it's working. When you define success criteria with these characteristics, you create accountability and give your team a clear target to work towards. Success criteria fall into 5 core categories. Business value measures impact like reducing processing time by 40%. Operational efficiency targets outcomes such as 30% fewer manual tasks. User experience focuses on improvements like 20% faster task completion. Quality and accuracy sets thresholds, for example, AI accuracy of at least 85%. And risk and compliance ensures governance, like 100% of solutions being reviewed before deployment. Notice these aren't vague aspirations, they're specific, measurable targets. You should work with stakeholders to define criteria across all 5 categories. Adoption goals prepare your organization to use AI at scale. They're broader than success criteria and focus on readiness across 4 dimensions. Organizational readiness means leadership alignment, AI literacy, and change enablement. Data readiness ensures your information is accessible, clean, and governed. And technical readiness confirms your infrastructure and platform can support the solution. And user readiness means the people who will use the solution are trained, supported, and motivated. Neglecting any of these dimensions creates bottlenecks that prevent even the best designed AI solutions from delivering their full potential. The Cloud Adoption Framework provides a structured approach to AI adoption planning. Start by defining the outcomes you want to achieve, then select the scenarios with the highest business impact. Assess feasibility to ensure your chosen scenarios are realistic, given your current capabilities. And establish governance frameworks to maintain quality, security, and compliance as you scale. This isn't a one-time exercise. Revisit these steps as your AI capabilities mature and new opportunities emerge. This framework keeps your adoption journey grounded in business value rather than chasing technology trends. This table shows how success criteria connect directly to adoption goals. If your success criterion is faster productivity, your adoption goal is user adoption, supported by AI onboarding sessions. If you're targeting improved quality, you need data standards supported by a governance framework. For reduced costs, the goal is workflow automation through Power Platform and AI flows. And for compliance, the goal is governance supported by responsible AI reviews. These aren't abstract connections, they are the practical links that ensure your success criteria actually drive the adoption activities needed to achieve them. Here you can see how success criteria, adoption goals, readiness dimension, and governance all interconnect. No single element works in isolation. Your success criteria inform what adoption goals to prioritize. Your readiness assessments reveal what gaps to close, and your governance framework ensures everything operates responsibly as you scale. Use this as a reference when planning your AI initiatives. It provides the structure needed to move from a promising idea to a measurable and scalable business solution. So let's review. You've learned how to build both task-focused and autonomous agents using Copilot Studio. from defining purpose and knowledge sources to designing agent flows that automate real business processes. You've learned how to implement prompt-driven conversational agents with adaptive responses using prompt actions and the prompt codes template to ensure consistency and quality. And you've explored how to define success criteria and adoption goals that ground your AI solutions in measurable business value. We've covered a lot in the session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching. Now you are ready to start building systems where intelligent agents collaborate and deliver.